Here we have something totally different to what I normally put on. Show you what they are, what they look like. We have two glass tubes with mercury in them, thermometer tubes, but they're different. They're not the normal type of thermometer tube you'd normally find. They are contact thermometers, but very elaborate ones. It took me a long while to work out how they actually functioned, and only recently the penny dropped and I realised how they worked. It took me a time. Anyhow, the reason they have these is to obviously control temperature on things by either switching a heater on or turning a heater off, depending on what the temperature is. And they rely on the conductivity of mercury and the fixing within the capillary tube a fine wire which is actually goes through the glass. It's sealed through the glass. I believe it's made of platinum, but I stand corrected on that one. It goes actually through the glass, makes contact with the mercury, and as the mercury rises or falls, the other contact, or the other side of the circuit, either makes or breaks, which controls a relay and a contact to operate something. I've shown it here in the simplest form. I must admit, I do like these unusual things. There's something to get my teeth into how they work. Here we have a diagram of a normal thermometer. There's the glass tube, the mercury bowl at the bottom, and the column of mercury which rises and falls to whatever temperature it is. Now we have at the lower point there one connecting wire which goes inside the glass tube, and it's set at say 32 freezing point. We have another contact which goes inside the tube. So as it stands at the moment, we can complete a circuit through the battery, relay back through there. As it stands, there will be a circuit. That relay will operate. If we have a look at the contact of the relay, and I've showed it separately, I haven't shared the batteries, I just showed it as to make it as simple as I can. You have the relay contact, which is shown in the normal state. That will be the state the relay is not energized. So as the relay has become energized, this contact changes and makes. That becomes a make contact. And in that state, the bell will ring. All the while the relay is operated, the bell rings. When the mercury drops down, or it becomes colder, the relay will release. That contact goes back to that state, and the bell stops ringing. Now you could, in fact, change that contact round. You could have that as a make contact when the relay releases. That way you would have the bell ringing when the relay released, or when the temperature dropped down below 32, an alarm is set up, the bell rings. As I've got it at the moment, it's the other way round. The bell rings all the while the relay is in circuit. Anyhow, that's basically how a contact thermometer works. The only problem is you are fixed on 2 points. Alright, you can add extra wires to it. You could put a wire in there or there to operate at different operating temperatures. You could have one in there, say 40 degrees F, 50, or even one lower. But you can't make it variable. You couldn't go between any 2 points that are fixed. There's no way you can do that, because they're by nature they're fixed. Anyhow, have a look in a minute at a type you can alter. As I said, it took me a long time to work it out. I picked up 2 of these. I've had them for a long time now, and we'll see how they work. Here I put in a simple arrangement how this is done. It's very clever. The mercury tube, obviously from there to there. We have the mercury, say, set at this point. There's one of the contacts. We're not too worried what we're going to set it at. Suffice to say that it's pretty low down. It would have to go way below that. So 20 is a good starting point. That's fairly cold. Now, the other end of this circuit is here. What we have is not a permanent contact through the glass, but it's got 2 tiny sprung contacts within the tube. Now granted, the tube is slightly wider than the normal capillary tube, so the capillary tube would in fact widen out at the point where it starts. So from here the tube becomes thicker, the bore is a wider bore. Now what we have, this little piece here, dumbbell or an insert or an inset, is made of magnetic material, iron or cobalt. Attached to it is a very fine wire. You can hardly see it, and it was that confused me, because I couldn't see the thing, but I can now. And that is obviously movable. With a magnet applied to there, a little horseshoe magnet, that becomes attracted, and you can move it, physically move it within the tube. And if you were to pull it up to the 100 mark, where the top of that index comes to the 100, the wire will obviously move up and will come to rest on the 100 there. So that moves up, the end of the wire moves up and rests on the 100. So what you've done, you've actually varied it to 100. Now you can move this anywhere within this range. So you have your variable contact thermometer, and within the range from here to there, it is completely variable. And that's how this system works. We'll have a look at 2 examples. One looks less complicated than the other, but they're exactly the same. Here we see the first tube. This tube is virtually identical to my little sketch. In fact, that was where I got my little sketch from. You look carefully, you'll see that little index. What we'll do, I'll show you it working. I've got a magnet, and draw the magnet over it. Hopefully we will move it. It's a bit difficult when you're holding the camera and trying to do it at the same time. There we are. You can see the index moving by the magnet. If we set it at 100, virtually set at 100, You won't be able to see the fine wire, at least I don't think you will. These cameras are good, but they're not, I don't know, you might just be perceptible. Yes, you can. You can just see the wire out the end of that index. Very hard. There it is, down the bottom there. There's your contacts. It goes through a sliding contact or a couple of contacts where the wire is held in tension, so it actually makes contact. I'm pretty sure it is a platinum wire. It's making contact there, and this then goes through the capillary tube, which is a thinner tube. It's where the mercury travels up, and it's a very thin tube. I don't know if I can show it. I'll try to. I might be asking too much of this little camera. I think it's just there. Now, I can't show it moving at the same time because I haven't got a dozen pairs of hands. But take it from me, that end of that wire, the platinum wire, should be at 100. I've set it at 100. So if we look at 100, yes, you can just see it. You can just see the end of that wire set at 100. And as I said, it is variable between the 110 and the bottom where the contact is. So that range you can have as variable. So it's a very, very handy device for regulating temperatures, checking a greenhouse or setting it at freezing point. So if it goes below freezing, an alarm is set. It is a form of thermostat, very similar form of thermostat, but quite an involved one. And that obviously goes down to the bulb of mercury. The second one is identical, but with one exception. Whereas the first one had the tube in a straight line, this one has it in a U-tube. We start at the normal place where the mercury is, the bulb, up through the tube. You start on your scale. There's your contact. There's the first contact. Follow the tube up. There's your second contact. Now that is the sliding contact which the thin wire passes through, making contact. We go round the bend, and once again you've got your little index, which you can see is magnetic. And while we're doing that, we may even, if I can show it, see it moving. Let's set it. Should be mid. Yes, you may just be able, just perceptible to see it moving. I don't know if you can. There we are. As I'm moving it, you can see the end of the wire or the platinum wire move down the tube. So like the other one, if we set this at 100 or 100, then the end of the wire will rest on the 100 position up there, and then you read, or then the mercury has to drop below that to break the circuit, because the wire, that wire there, will end there. So it's like you fixed it on there by positioning that. That's set at about, what's that set at? Actually it's set at 80, so I've told you a little bit wrong. Try and make it correct. It's difficult, the light's shining. Now we've set it at 80, so the pointer will in fact end there. I wish I could show it, but there's no way I'm going to be able to. Very, very difficult. It's a very, very fine wire. But anyhow, that's how this little device works. I picked these up, I don't know where from. I go to so many different places, boot sales and flea markets. Look at the back, you see the wires, 2 wires, and they come through the glass and they terminate inside that little screw top. If you take that cover off, there's 2 terminals, and it's the same in both cases. I think these are German made, I'm blooming sure they are. Someone out there will know. It's a VTAX DRP, and the number is NR, so it's written the German way. There's the number, just see it. 683085, and you note the German number NR. Let's have a look at the other one. That's got a name down there, or initials, DRP. That's the only name that's got on it. That plug of material is obviously to hold the tube firm so it doesn't shake about and get broken. Anyhow, that's the variable contact thermometer. If you're using one of these, make sure that the switching contacts only experience very low current rating in milliamps. If you have it high, it'll just burn the tips off, and once the tips are burnt off, it will no longer work. So it does not want to spark in any way. You could in fact connect a spark quench capacitor between the 2 points. That would certainly help to reduce sparking, but make sure it is very low current. A normal relay possibly would not work. I'm using it as a demonstration. You would probably have to use a transistorized circuit, but nevertheless, I thought I'd put it on there. I hope I haven't been long-winded. Any questions, please ask, please comment, and please subscribe. Thank you again for watching. Thank you.